Chapter 14, Section 4, Regularization, Part 2. In the previous video, we saw L1 and L2 regularization, also called lasso and ridge, respectively. In this video, we will explore other popular regularization methods, dropout and early stopping. Dropout is a method that lowers the complexity of a neural network by removing neurons. Dropout randomly selects neurons in the hidden layers and removes them in the training process. For the removed neurons, the signals flowing from the input layers will not be transmitted. It is as if signals will ignore the removed neurons. The neurons to be removed are randomly selected for each epoch. So, probabilistically, every neuron in the middle layers have the same probability of being removed. The probability that each neuron in the middle layer will be removed is called dropout rate. Usually, we set the dropout rate to 0.5. In dropout, we select the neurons to be removed randomly for each epoch. So, in each epoch, different neurons will be selected to be removed with the same probability. Therefore, using dropout means that we use different models for each training. So, the model works like an ensemble learning method. By using multiple models, we can reduce the possibility of falling into overfitting. Then, we can enhance the generalizability of the resulting model. Early stopping is another regularization method to prevent overfitting. It focuses on the number of epochs. Up to now, we have focused on model complexity as a cause of overfitting. But too many epochs can be another cause of overfitting. Early stopping is a regularization method that stops training when parameter updates no longer improve the model performance. As we can see in this plot, as the number of epochs increases, the training loss keeps lowering, suggesting that the learning is progressing well. However, from a certain point, only training loss continues to decrease, and the validation loss does not improve, remaining flat. This indicates that the model is beginning to overfit. If you continue training when this tendency occurs, the model will only fit to the training data, and the degree of overfitting will worsen. In this case, you should stop training early to prevent further overfitting. This is called early stopping. Other than artificial neural network, there are various types of neural network. This chapter has focused on artificial neural network. Convolutional neural network is effective in dealing with image data. Convolutional neural network is designed to efficiently extract spatial features from image data through convolutional layers, making it particularly effective for tasks like image classification and object detection. Recurrent neural network is effective dealing with time series data and language data. Recurrent neural network is designed to capture sequential dependencies by retaining information from previous inputs through hidden states, making it effective for time series and language data, where the order or sequence of the data points is important for understanding the context. Details of these types are beyond the scope of this course. Let's summarize the points in this chapter. Backpropagation is the process of updating a deep learning model's weights by calculating the gradient of the loss function with respect to each weight and using gradient descent to minimize errors. Optimizing a deep learning model involves adjusting the model's parameters using optimization algorithms like gradient descent to minimize the loss function. Regularization methods such as L1, L2 regularization or dropout add constraints or penalties to the model to reduce complexity and prevent overfitting by discouraging the model from fitting noise in the training data. Thank you for watching. Please thumbs up and subscribe to my channel.